Hello and welcome to the section Beyond SQL Server. This section will be an exciting ride through the rest of the different features like the query store and the temporal tables that will provide you with additional information to enhance your knowledge. Now we move on to the first video of this section that deals with the query store. In this video we will learn to activate the query store feature and set the maximum size of query store and size-based cleanup mode to auto. Also, we will see how to access the content of the query store. Sometimes you will notice that perfectly fine queries will show weak performance for no particular reason. One of the reasons for this could be the change of the execution plan. An execution plan is an internal result SQL Server procedure where the engine needs to decide the best possible way to execute your query. Each query has its own plan. During standard database operations, based on internal statistics, those plans can be changed, but the results are not always better in terms of performance. On the contrary, they can be the exact opposite. Before SQL Server 2016, it was not an easy task to investigate these problems. You were facing these two issues: TTD, that is, long time to detect the issue, and TTM, which means long time to mitigate. The main reason for this is that the fixing query plan that causes regression is a difficult task to perform. The query plan is not designed for performance troubleshooting. Fortunately, we have this great feature. Query Store provides you with an insight on the query plan choice and performance. It helps with performance troubleshooting by enabling an option to find performance differences caused by changes in query plans. Query Store automatically captures a history of queries, plans, and statistics, and keeps them for later review and analysis. This allows you to observe database usage patterns and understand where query plans changes occur on the server, and lets you force a particular plan for a specific query. So, let us see how to activate this cool feature with the coming steps and use it on your own queries. Let's log in to SQL CMD with your credentials. Now, the query store is not a feature that automatically starts, and you will need to turn it on. Here, we use AdventureWorks 2014 sample database. Next, alter database, AdventureWorks, set, query, store, on. If you want to see more detailed information of what is in the query store, run the next query. Let's type, select T3 dot query text ID, comma T3 dot query SQL text, T2 dot plan ID, T1 dot asterisk, from sys dot query store query as T1. Also, we join sys dot query store plan as T2 on T2 dot query ID equals T1 dot query ID, join sys dot query store query text as T3 on T1 dot query text ID equals T3 dot query text ID. Let's run this query with the go command. We can now see the detailed information of what is in the query store. Please consider this query is visually very inappropriate for the SQL CMD interface. The console is not created for this kind of stuff. Because you have activated this feature, you will not see anything spectacular, but if you run the same query a second time, you will see it on the list. Later, you will see how the number of records your database is working on will rise. This query will give you a handful of insightful information, such as query text, plan ID, compile statistics, duration, CPU, memory, and optimization details. Based on this, you can compare which plan is performing better and force SQL Server to use that particular one. You should consider purging query store data based on your needs. This can be done through a set of query store parameters that you can configure through the alter database statement, which gives you more control over the whole process. Here are some of them listed on your screen, which you can use depending on your needs. Let's take a couple of examples with these options. Here, maximum storage size is fixed to 150 MB. Type the query alter database AdventureWorks 2014 and we set query store with maximum storage size with 150. Also, maximum size of query store and size base cleanup mode is set to auto. So let's continue writing the query for this. Alter database AdventureWorks 2014 and set query store max storage size in MB with 150. Size based cleanup mode is set to auto and cleanup policy is equal to stale query threshold days equals 15. After this, we purge all the data inside the query store, alter database, AdventureWorks 2014, and set query store clear. Now, for queries that are executed more than once, you may notice that SQL Server used different plans, which resulted in different resource utilization. Query Store can help you easily detect when the query performance regressed and determine the optimal plan. Based on that information, you can force the optimal plan for query execution. For demonstration purposes, you can use the heavy query on the AdventureWorks sample database, which I'm going to show you now. Select P, dot, last name, comma, P, dot, first name, and EA, dot, email address, PP, dot, phone number, CC, dot, card number, P, dot, first name, plus, P, dot, last name. Now define substring to reverse last name. Similarly, for the first name and cast, from, person, dot, person, as P, with inner join, person, dot, email address as EA, on, P, dot, business entity ID equals EA, dot, business entity ID. We create another inner join. And here we go. You will get something similar to this, depending on your database that you are working on. After this, we will run a query to access the content of the query store with a simplified version for the purpose of reducing the number of columns and adjusting the output to the Bash console window. Let's write the query. Select T2 dot plan ID, comma T1 dot query ID left T3 dot query SQL text, comma 15 from sys dot query store query as T1. We create a join sys dot query store plan as T2 on T2 dot query ID equals T1 dot query ID. Join sys dot query store query text as T3 on T1 dot query text ID equals T3 dot query text ID. In the time that it takes to do this, the plan can change and show regression. Examining query store, you will probably notice that the first version of the plan was performing better. This hypothetical scenario is the ideal candidate for the forcing of the plan. When the plan is forced on a certain query, every time a query comes to execution, it will be executed with the plan that is forced. The next code will force SQL Server to use plan ID 1 for the query. We now go ahead and write this query. Execute sp query store force plan at the rate query ID equals 1 and at the rate plan ID equals 1. When using sp query store force plan, you can only use plans that were recorded by query store as plans for that query. In other words, while query store is active, if you want to remove plan forcing for a particular query and rely on the SQL Server Query Optimizer, you can use sp query store unforce plan. Here's how we do it. Execute sp query store unforce plan at the rate query ID equals 1 at the rate plan ID equals 1. So we have removed plan forcing on this query plan. The query store feature is a great tool that can make your life much easier when you are stuck with performance issues. It's just a matter of time until this happens. Dealing with query store is more user-friendly through the SQL Server Management tool. So, if you have access to this tool, give yourself some time and explore it. Eventually, the new SQL Server Cross-Platform Administration GUI tool, which is in development, is expected to support many SSMS features and bring them to the Linux platform. In this video, we have learned about query stores,